we? Okay.
Hello, everybody. We are just waiting for a few extra joiners, so bear with us. We'll give it another few minutes. So we'll just wait another minute till 25 to, and then we will commence. Okay. Hi, everybody. My name is Peter Lakin, Vice Chair of the Birmingham and Black Country Club. Welcome to today's webinar, which will be focused on the National Brownfield Institute, which is an important part of the Springfield campus and adjacent to Wolverhampton Station as part of the Wolverhampton University campus there. I think this institute, Andy Street says, will help the West Midlands become a global leader in the cleanup and regeneration of derelict sites with the housing shortage, etc. It's obviously a key item that we need to address and get some sites that previously weren't developable back into circulation. Today's presentation will be led by Simon Kendall from Faithful and Gould, and it will be focusing on innovation and collaboration in design and procurement, which are all obviously close to our hearts. So without any more ado, I'll hand you over to Simon. Thanks, Simon.
Thank you, Peter. I'll just share my screen now so that I can share the presentation we put together for you. At the moment, all I can see is Simon Kendall, so hopefully it will share shortly.
Yeah, it's sharing for us.
Yeah, it's sharing for you.
Yeah,
That's good. Yeah. That is good to know. Then I'll crack on. Oh, sorry. I'll get this right eventually. Always a bit of a newbie when it comes to presenting on the internet. There's always a new challenge to face. Right. Well, thank you very much for your time today. Obviously, we'll just run through a very quick overview of the project and give you a little bit of highlights around some of the background to the project. Collaboration has been at the heart of the scheme from the very outset. The concept for the scheme was a collaboration between the University of Wolverhampton, construction and development industry partners, and the Wolverhampton City Council, as well as the Black Country LEP and the West Midlands Combined Authority. It wouldn't have progressed without the support from everybody. I mean, the National Brownfield Institute itself will become a state-of-the-art research and innovation centre. It'll feature commercial testing facilities and lab space, and will be the home to a national policy institute, which will inform and guide future strategy development around brownfield regeneration and give specialist advice on dealing with contaminated land and repurposing buildings and sites. It's directly supported the regeneration within the Black Country and the West Midlands, and will support delivery of the 215,000 new homes by 2030, and hopefully act therefore as a catalyst for development. The project vision, as you say, is to create a world-class brownfield regeneration industry cluster through sort of collaboration with industry partners as well as academia. And it was facilitated by the Get Britain Building Fund, and the budget was set prior to the finalisation of the design, so it was very much a design to and build to budget, and has delivered on all of that to date. Just the next slide. It was an extremely aggressive delivery program. We were asked to pull together a team, so we used a team who are actually familiar with the site, having been involved in delivering an earlier project, and actually to take on board the brief and concept for the scheme. Started REBA Stage 1 August 2020 and completed the contractor engagement and had tender submissions back in December to be able to enter into contract in January 21. So hopefully you'll all appreciate how accelerative that whole process was. We brought the contractor on very early. We used the contractor who delivered the School of Architecture and the Built Environment, particularly again because they understood the site and the constraints therein. The site was previously developed. It's a brownfield site in its own right. The Springfield Brewery. There'd been fire damage to the original brewery buildings, and the area that we were going to use had previously just had a lot of debris and sort of spoil heaps mounted on it. So lots of issues to consider. Some attempts at the redevelopment of the site prior to the university purchasing the site had sort of also created some issues for the site, which we had to overcome and manage. But obviously, this is the next phase on in the development of the site overall by the university. There was the University Technical College, which is on site. The ECMS, the Engineering Centre for so was one of the previous schemes, which again reused the stable blocks, and then we've got the Elite Centre for Manufacturing Skills, and then the School of Architecture and the Built Environment was the latest version or project to kick off prior to then the MBI. Now the team, as I said, got very familiar with the site and the constraints therein, having delivered the School of Architecture, as you can see there, which immediately is adjacent to the MBI site. And from that was the reality of the school, breathing new life into those existing buildings, which are a landmark within Wolverhampton. And again, we needed to make sure we were celebrating the existing buildings and the historic content of the site. Equally then, in considering the NBI building in its own right and its the site selection for it, we had to make sure we were tying into the overall master plan, and the site was chosen to actually reflect and respect the previous historic line. So there was the old railway sidings that used to pass through the site, which is one of the focal points within the site master plan, is maintaining that central corridor where the railway lines went and utilising the space adjacent to on either side of that for the developments. As part of the brief, one of the key aspects that we were looking at was the incorporation of modern methods of construction. And obviously, in such an accelerated program, there was only so many things that we could consider, but we tried to ensure that we picked up all possible avenues for modern methods of construction, componentized construction, and to make sure that we had a sustainable delivery process in place. I'll now hand you over to Joe, who will be able to talk you through some of the plot developments in terms of how the scheme developed from that point onwards.
Thank you, Simon. Yeah, good afternoon, everybody. I'm Joe Belcher from Associated Architects. It's really good to be able to join you with today. So the key drivers in the concept design were really twofold. There's a big emphasis on design efficiency, delivered through a compact building form, maximising the usable space for the budget, and in terms of below ground constraints, and then also townscape issues of how to deliver a building in close proximity to the historic context. Now, we delivered a quick but kind of wide-ranging options appraisal, different plan forms, considering volumetric modular approaches and different footprints to the site using the 3D models available, as you can see here, and settled on a wedge form construction. If you just flip the next slide, Simon, that'd be great. And all the way through that process, we're able to use the models to undertake real-time analysis of the impacts of each of those on the net areas available and compare that to briefing requirements. As I mentioned, it was really key that there was an efficient response to the below ground constraints. Simon mentioned some of those issues. There'd been a remediation process undertaken already, so we were keen to minimise removal of material from the site, and also there's a number of HV cables as well as other LV and data cables and stuff on the site. So the development of the plot and its levels was all driven by that. We're able to test a number of townscape concerns, the views from the railway viaduct adjacent to the site, and also relationship with the SOAB building that you see on the bottom right hand side with the sawtooth roof that we'd recently completed. So here you can see this kind of the design resolution, really how it has ended up. It's a relatively simple form, wedge shape, two-story building with a protruding section at the far northern end, which accommodates a plant screened area and also helps to emphasize the entrance end of the building, which is helping to draw people further into the master plan site as it gets developed through the future. So as I mentioned, using all the digital design tools that are available to us has been really important to enable collaboration amongst the whole design team to get us to work to this aggressive delivery program that Simon alluded to. And I think it's really important to mention that the key to all of this is healthy models, reliable models producing reliable design information. And so we conduct regular model health checks. We're serving as architects, lead designers, and BIM lead coordinators in this project. So it's been great to work together as a team on this. And you can see here visual representation of the structural frame and below ground structure. And on the next slide, you'll see the landscape added. And the next one, the services on their own and then together. And this is kind of what we began as a core design team with landscape, civil structures, and ourselves and MEP has now been progressed through the site delivery stage. We're now a few months into site stage work, and we're integrating the models of specialist subcontractors, for example, the steel frame, light steel frame SFS systems, and structural staircases and the like. So it's a process which is continuing, and that's really important to ensure that all the advantages generated early on are maintained in terms of coordination and smooth delivery on site. We're using a tool called BIM Collab to enable collaborative review and recording and addressing of coordination issues, illustrated in this slide as a sort of thumbnail summary. So here we see the structural frame and the coordinated services together, and finished up wrapped in the external envelope, which is an aluminium rain screen cladding system. So that there you see this, the complexity of the various models. That's just the three main models from the core design team at an earlier stage of the process. Okay, so external envelope, as I mentioned, it's a aluminium rain screen cladding system, which we developed to sort of meet all the requirements for cost and appearance on the site. It's a generally silver appearance with some feature areas in a sort of deep red wine kind of colour, picking up on existing textures and colours on the site. And obviously, as well as traditional 2D outputs from the model, behind that, there was a lot of extensive use of the model. If you see on the next slide, Simon, where we could do processes optimizing cladding panels, for instance. So here you can see we run some simple analysis saying, well, you can see that we've really driven it down to across all the whole cladding panel. There's a whole cladding system. There's only a vast majority of them, 75% of them, are the same width, sort of 750mm modules. Very few deviate from that at corners and the like. So we can use the model to really drive design optimization, demonstrated by this example. Next one. Next slide, please. There we go. And a similar process was undertaken through optimization of the glazing on the building as well. It was a clear kind of client directive to really focus the glazing areas, and we were able to demonstrate the processes that we were going through iterations of the design, and use the model to generate quick and accurate estimates of that. So here you can see some demonstrations we produced of the scale and how it relates, the views from the viaduct, and the relationship with that sawtooth roof of the SOAB building recently completed. Okay. If we just flick through these. So moving to the internal arrangement, as I mentioned, it's a simple two-storey building. You can see the plant on the roof to the right-hand side there. And the ground floor, I'm going to talk through first. So ground floor arrangement, you can see there, it's a very simple plan, really, key to the efficiencies. Key drivers, obviously, the main function on the ground floor are brownfield related research laboratories. Key drivers being flexibility and efficiency in the building structure, the spans, the planning grid, optimization of glazing, and the layouts there. And here you see a sort of an axonometric view of that arrangement. The labs are all clustered in a efficient group together at the top end of the page there. The entrance towards the middle, and some admin areas right up on the front corner, with core and plant areas, data center, etc., tucked in the corner there as well. So within the laboratory zone, the requirements here is a space which is available for external commercial partners to come and to take space, or to collaborate with the university on research into issues related to brownfield sites, contamination of various kinds. And so there are different labs which are intended to focus on different types of contamination and site issues, such as asbestos or various organic materials, metals, and others. And there's a range of prep spaces there. So it's a cellular arrangement rather than open plan, which supports various alternative uses of the spaces by different users for different functions, adaptions over time, and specialist environmental conditions in particular labs, which wouldn't be available if it was a single open plan space. So the next few slides just take us through some simple visuals to give you a flavour of the spaces available. Oops, there we go. This is a write-up office that's associated with the laboratory spaces, and an office area, meeting room. And here we are in the central laboratory spine corridor with really good visibility into each of the labs through those glazed screens. Very early on, we developed ourselves a laboratory fit-out model. So it's all considered from an early stage, which really helped the client to understand what it is that we're proposing, what they're getting, and refine that, and also deliver really accurate tender information that could be accurately priced. And you'll see the schedules and linked to MBS and all the rest that we have on the next couple of pages. And here demonstrate the coordination between the structure, the fabric, and the services, which is really crucial on these heavily serviced lab areas. So the 3D model, the layouts, the quantities, the specification, all linked together through the 3D model. and likewise we can optimize the design and keep a clear track on how on the data, the quantities of various kinds of provision, worktop areas and stuff like that, through the iterations of the design.
Just to reinforce as well, Joe, obviously we'd been driven specifically to get early contractor engagement on here to be able to deliver the project in the timescales and time frame we had. And obviously it was really important to get their buy-in and support in making sure we provided the right sort of information in the right format for them, and to get the support of their supply chain through this as well.
Yeah, that's right. Thank you, Simon.
Yeah.
Okay, next slide, please. Okay, so we're going to move up to the first floor now. And this is the function of this space is really a digitally enabled collaborative work area. The university intend to run professional training events, CPDs and that kind of thing, but also for the space to be used by project teams to be able to come and plan and develop their project proposals for the reuse of brownfield sites. So it's very technology enabled through its fit out, and key kind of flagship element is this 360-degree immersive cylinder, where there's projection on all sides, which we'll see in some later slides, where here we are, where project teams could come and view and review various sites linked with various below ground survey data, record information of contamination, of below ground conditions, various issues related to constraints really that may have held back brownfield redevelopment previously. The idea is that within this space, in a suite of spaces, new solutions and development opportunities will be unlocked. So flexibility and efficiency, again, key things, health and well-being in terms of daylight and provision. So the next few slides again show some visuals of the kind of space. This is the arrival up from the ground floor, and this is this 3D 360-degree immersive cylinder externally sitting within the space, and the kind of facility that might be on the inside. Obviously, any number of things could be projected on those surfaces, combining data and visual imagery. So outside of that space are the wider sort of collaborative spaces, where breakout opportunities from that main internal cylinder would take place. And over the other side of the building, there is a tea point refreshments area and further open plan breakout spaces. Lots of flexibility in how these are used. There's a kind of boardroom style meeting room, a range of seminar spaces, meeting rooms, and also an office for the regular workers within the space as well.
Yeah, I mean, the key focus for this was around, again, collaboration. It's allowing bookable space for the wider community as well as the university to use. So any visiting professors, any visiting researchers. So the whole space was driven around having flexibility and collaboration at its heart. So sorry about the interruptions. I have to quickly take myself off mute to be able to interject.
No, that's good.
Back to yourself.
Okay. Okay, so next few slides just demonstrate as you've probably got a flavour of the holistic approach we're able to take to architecture, structure and services. So here's the architectural wrap to the building. Sort of 2,700 components within the model at that point. The structural frame and piling is 850 elements within that model at that particular point in time. You see the piles there, and next you see the services, obviously very heavy on the the modelled elements there with the complexity of the MEP systems. And then all together. So I'm going to hand over to Dan Maddy from Atkins to talk through the structural and civils approach to the scheme.
Yeah, thanks, Joe. Hi, everybody. My name's Dan Maddy. I'm from Atkins. I'm a structural engineer, and I had led the civil and structural design on the NBI project. So I'll just talk for a couple of minutes about our general approach. As you can see from the slide, structurally it was quite a straightforward structure, but we really kind of spent a lot of time and focus on kind of optimizing it. And due to the aggressive program, it was all about kind of coordination and collaboration and getting the design completed as quickly as and efficiently as possible. So yeah, just a few minutes talking about the civils to begin with. So if you go on to the next slide, please, Simon, or whoever's driving. So we started off with the drainage. So the slide before this one, please. It's got the surface modelled. Yeah, there you go. So yeah, we modelled the drainage at quite an early stage to make sure that was in line with the existing site-wide infrastructure that was installed as part of the master plan. So a lot of the infrastructure-wide drainage and attenuation was already in, and we obviously had to tie into that. So through the use of 3D modelling of the surfaces and a site-wide assessment of the overall drainage, we were able to kind of really optimise the attenuation that was required on our specific plot, whilst also kind of reducing the amount of attenuation that would be required on future plots and maximise the developable area of those. Also, modelling the 3D really helped us kind of fine-tune the position and the level of the building. So through the course of that exercise, the position of the building moved to make sure that we were minimizing the amount of material that was excavated from site, as Joe mentioned earlier, and also completely avoiding the need for any retaining structures, even though there is a considerable change in level across the site through the 3D model and making sure that things that are supposed to be buried are buried, and kind of really fine tuning it allowed us to optimize that really effectively. We've got some SUDS elements on the scheme. We've got some permeable paving in the car park, which provides some water treatment and further reduces the need for attenuation tanks. And another advantage of that was that it reduced the amount of dig required in the car park, where we've got the high voltage cables that Joe mentioned earlier as well. So yeah, that's about it on the civils. Moving on to the structures, again, modelled in 3D. With the surfacing, allowed us to really optimize the level of the pile caps and the substructure. So as you can see in this model here, the pile caps and the ground beams, they're not all at the same level. We've really responded to the proposed external levels, again, to minimize the amount of excavation, minimize the amount of sacrificial additional piles, the trimming of the piles. We've got two different piling maps to really kind of optimize the amount of imported and exported material on the site. In terms of the superstructure then, as Simon mentioned earlier, one of the huge factors on this project was the very aggressive program and getting to site as quickly as possible to meet various funding targets, and that had a large impact on the structural solution. There was a large appetite early on to investigate and showcase modern methods of construction, such as modular, which we looked into quite a lot. But we were also quite conscious as a design team that we didn't want to crowbar those solutions in just for the sake of it. We wanted to take a pragmatic approach, as we would on any brownfield project, and use the most appropriate solution. And with all projects being different, on this project, program was king. And whilst modular solutions save a lot of time when you're on site, they don't necessarily get you to site very quickly, because there's a lot of design and coordination to be done with the subcontractor and what have you, which led us down the route of a more traditional steel frame, which is the solution that we've ended up with and that you can see on the screen now. So the advantages of that are that it's still relatively quick to fabricate and erect on site, and most contractors are very familiar with that form of construction. In terms of the floor construction, that was really developed to suit the MEP. As Joe mentioned, it's quite a heavily serviced building with the labs and what have you. So we considered several options, including composite precast solutions and cellular beams. But the option that provided the minimal combined structural and MEP depth and provided the greatest flexibility for MEP both now and in the future was a composite solution with relatively closely spaced secondary beams that kept everything nice and shallow. And as you can see on the screen there, it allowed the MEP to pass underneath, but whilst keeping the overall depths minimal. We've got the same construction on the upper roof, which is also acting as a plant deck, but there's no significant plant on the lower roof, so we were able to keep that nice and lightweight using cold rolled purlins to reduce overall steel tonnage. As we can see on the screen there, we coordinated very closely with MEP to size and position all of the openings required for the ductwork and make sure that there were no clashes when we got to site. And as well as openings, making sure that all of our primary beams and where we've got changes in roof level weren't going to block the roots of anything and cause any clashes. So we had regular model shares, we were sharing the model every week at the peak of the design process and making sure that we were all keeping up to date with the models and running regular clash reports to make sure that everything was working as it should. So yeah, that's about it really. As mentioned by the other members of the team, close collaboration was really key on this project. We were able to get from feasibility stage in August of last year to a start on site in the February, which is a testament to the value and the effectiveness of that BIM approach and the regular model sharing. So from that point of view, it's been a great success. And so far, touch wood, everything's going really well on site. I was out on site a couple of weeks ago, and it's progressing at a rapid pace. So yeah, so I'm now going to pass over to Antonius of Couch Perry Wilkes to talk about the MEP approach and how that fit into the overall design. So over to you, Antonius.
Thank you, Dan, and good afternoon, all of you. My name is Antonius Akipakis from CPW. We're mechanical electrical consultants working alongside the rest of the team from inception all the way to construction stages. As part of our energy and sustainability approach, we reviewed the infrastructure of the building. We connected into the local utility services providers for incoming power and mains cold water, and to future-proof the building and in line with the government's carbon reduction and universities' carbon reduction plan and grid decarbonization. We have no mains gas supply into the building and no traditional boilers for heating and hot water. We're using something future-proofing as far as the building's concerns, which will be air source heat pumps. It's something that it's out there and available, and the government is really pushing hard as far as the grid decarbonization concerns and the carbon reduction plan. Similarly, our sustainability approach and the low carbon roadmap for the building design, and in collaboration with the rest of the team, especially on the architectural front with the building orientation, was to optimize the location of the building, the glazing percentage of the building, to ensure a very good thermal envelope, daylighting into the building on various areas, and more importantly, the services that have been designed to serve the building were in line with the program, in line with the very important, obviously the cost, but the running cost of the building, which is more important for the years to come. Now, to give us all the credentials as far as the clean and green energy concerns, air source heat pump have been incorporated for the low zero carbon solution in line with photovoltaics into the roof to give us the APC that we required. Innovations for the building, I mean, we did touch earlier on the modularization, and we did test all the services on the roof space and the offsite manufacturing facilities to ensure that they can be delivered on site in modules and installed in line with the program. The photovoltaic is very important for the installation of them, and in line with the renewable energy contribution for the local planning policies will give us the credentials that we need as far as the decarbonization concerns. With the labs and the rest of the offices, the building is fully mechanically ventilated, so we have ensured that the heat recovery through the ventilation plant will give us that extra energy saving that we need, not just as a installation, but more importantly, as a long-term operation of the building. The air source heat pumps on the roof space, it's something that will ensure that the decarbonization of the grid will be forming part of this building for long term, and it's in line with the local policies as well. I think overall, you can see the plant, and we're trying to accommodate everything in one place, and it works really well on site at the moment. Over to you, Simon. Thank you very much.
Yeah, no, thank you very much, Antonius. Yeah, I mean, the whole collaborative approach has fed through the entire process, as we've said, but to ensure that there was absolute consistency and that the university's approach was aligned to all of the key deliverables and outputs, the university felt it was really important to actually put a bit of challenge back into the team as well. That the existing team that started all of the pre-contract work had migrated across from a previous project, the same contractor as well. So it was really important to get some challenge in there and ensure that there was some proper duress put into the post-contract process. And that's when Mace were introduced as project managers to deliver the post-contract period. And I'll hand over now to Jack to explain that to you.
Thanks very much, Simon, and good afternoon all. I'm Jack Duthie from Mace, and as Simon just alluded to, we were appointed as the NEC project managers for the construction period of the MBI. The former contract used was the NEC ECC option A. Simon, if I could just ask you to click on to bring up the text. Thank you. So the NEC contract has really driven the collaboration between the client and contractor during the construction period. To facilitate that, we've established weekly review meetings, both the client and contractor in attendance. They're in addition to the sort of standard project engagement meetings that we'll have regarding designs and decisions and change, etc. But as part of that weekly meeting, and something that's been really key to the progress made on site, is the early warning notice review. Again, having both parties present at a weekly occurrence to be able to review, discuss and collectively agree solutions and or actions to progress each item has put the project in a good position. So as previously mentioned, the project has an aggressive programme. In particular, the completion date is fixed for the university, and so the NEC contractors are allowed close review and management of the programme. As the construction activities progress, we are obviously keen to ensure that all milestones are achieved, and as part of that, the contractor issues a revised programme showing the latest position at maximum intervals of 3 weeks, and we review that or assess that with frequent site visits, and also using the cash flow forecast as a tool to ensure that what is being reported accurately reflects what is on site before accepting the revised programmes. So currently we're at CP09, so we've had 5 iterations of the programme since starting on site, and expecting the next one in the next week or so. But the benefits gained from this close working and collaborative approach has shown that we're currently forecasting 1 week ahead of planned completion against the contract programme. So as you can see, the construction activities is in a really good position to maintain the programme throughout the project. And I think, Simon, if we're able to click onto the time lapse, we can take the brief overview of the construction activities to date.
Sorry, Jack, I did try sorting that through prior to the start of the meeting, and I found that it was too much for my bandwidth on my Wi-Fi. I think it ended up with really poor quality. So what I've done is I've just included a couple of slides, or a slide, which just shows the model project against some progress photographs, and hopefully you can just sort of describe some of the progress that we've made through those.
Yes, yeah, absolutely. So top left, obviously, you can see the artistic illustration of the finished project with SOAB on the right and the new NBI to the left. And the photograph looks up the spine road that Joe mentioned, reflects the previous use of the site, being the railway sidings. The top right photograph, clearly see the steel frame in position. Not sure if the slabs are shown on that photo, but both slabs are poured, as you can see by the photo below that. And the activities on site, we've commenced the SFS, the external hard standing. The majority of that's installed to give the contractor a good working platform to complete the job. And the roofing has started this week, so it does reflect the updates we've had via the revised programmes, showing that the project is in a really good position moving forward, and we hope to maintain that for the duration of the project.
Yep.
So thanks very much, and Simon, I don't know, perhaps we might be able to share the link to the time lapse via an alternative route for those that are interested.
Yeah, hopefully we can. We'd obviously just need to get authority from the university to share that. If I stop sharing my screen, well, in fact, I'll show you why. I'll stop sharing now. That's great. Thank you very much, Jack. Hopefully, if anybody does have any questions now, we've allowed a 15-minute slot at the end of the allotted time to take any questions and answers from the floor. So. Just seeing the Paul. Thank you, Paul. Yes, there's been a lot of hard work gone into the project overall, and it's quite gratifying to be able, on behalf of the whole team, to present the endeavours that we've gone to in the outputs. To be able to showcase them in this way, it's great. So thank you for the opportunity. I don't know if there's any other questions that anybody wants to raise. I don't know if they need to be raised in the chat pane. Not seeing anything appear, so I'll do my usual thing of starting to talk then. And as I say, that the whole process of this from start to finish has been collaboration at its heart. The design team were chosen because of their knowledge and experience of the site and experience with the planners. There was a very close liaison with the planning authority and the heritage architects and the planners, purely around all of the issues of developing a listed site, not just the issues we were going to face with a brownfield development, but that sort of background and dialogue has put us in really good stead, and we've had no hiccups with this project whatsoever getting it through planning. Despite the fact that we've had to do several sort of last minute changes to the design to incorporate some of the requirements of making sure that we did design it and deliver it to budget, which is we're well on way to doing. So I've seen that.
Hi Simon, Peter here. I'll just put one on the chat function around sustainability. Sorry if I missed it, but were there any specific sustainability targets and measures that are or were incorporated?
Yeah, in terms. Oh, sorry, Antonis, you want to?
No, that's fine. Sorry. Thanks, Peter. I was actually replying to your message. You sent me a direct message, so thanks for this. Our sustainability approach and focus was on the passive thermal envelope and the efficiencies. As far as the energy targets concerns, we were with the local planning authority 10% on renewables, but we went beyond that as far as the building operation concerns for energy and carbon reduction going forward for the future. So 10% betterment of the building regulations, but the building has been future-proofed for new technologies coming into the future.
Yeah, I mean, sustainability is at the heart of the project, but it's been its focus is around actually low energy and low cost in use. BREEAM very good has been the target, but it's been the energy targets have far exceeded the requirements of BREEAM very good.
Which I think makes a lot of sense. I think BREEAM is a bit of a snapshot at construction stage, and for me, it's more the life cycle of the building. There's far more,
and that has been fundamental to a lot of decisions made. So the amount of glazing, the accessibility, the types of materials that have been chosen, both internally and externally. It's all been driven around sort of ensuring that the project is sustainable
Yes.
throughout its life.
Just to add on that, Simon, as well, the very important thing as well was not just the tender information or the targets that we had during tender. We follow that throughout the construction stages, and we're working very close with the contractor and the rest of the team to ensure that these targets are met.
Yeah, absolutely. I mean, I see Paul Slinger's asked a question of how central was the model as part of the tender process. As we mentioned, we followed a two-stage tender process, but basically negotiated with the contractor who's already on site, having delivered the School of Architecture and the Built Environment. They were fully embedded as part of the team. They weren't sort of left to receive information and deal with it. They were party to the design team meetings. They had access to the model throughout, and it was a fundamental component within the tender. When they submitted their final tender, the model was at the heart of it.
Great, thank you. There's no other queries come up on the chat function.
Okay.
Currently,
the building's there to be used. So if yeah, and I'm sure Arif, who's the sort of the powerhouse behind the scheme's germination, if you like, and delivery, would welcome anybody wanting to sort of hire space, use space, and make use of the facilities. It's there as a resource to be drawn upon.
okay. In the absence of any other questions, I'll just wrap up and just say thank you, Simon and the team. So obviously good luck with the delivery of the project going forward. So it will be a fantastic asset to the region, I'm sure, and one that, you know, really I would encourage everyone to take interest in, and when it's up and running to use. As I said, it's an asset to the region. So thanks very 100%. Much for your time. Yeah.
Yep.
Much appreciated. Okay.
Yeah. Thank you very much, Peter. Yeah, and from the whole team.
Yeah. Thanks very much.
Yeah.
Thank you all.
Yes, thank you very much.
Thank you very much.
Thank you.
And we deliver the presentation as we intend to deliver the project, early and to the right quality standards. Couldn't resist. Cheers all. Thanks.
Thank you.